Okay, so everything's set up, and the first thing we do, we'll make sure our list is initialized, that it's sorted, and also that we have our target value, which is 28. So we're going to set low to 0. Then we're going to set high to the length of the list minus 1. So low will be 0, and high will be the length of the list, which is 16, minus 1, 15. So that's the index of the high. Then we're going to calculate the middle value, and it's this idea of getting the low plus high, kind of divide it by 2, but round it down to an integer. And to do this, of course, we use a floor division to allow this to happen. And so fitting in that formula, low plus high, floor division 2. Now, this is where our if statement comes in, and this is basically our comparison. Compare the middle item to the target. So if the value at the mid position is the same as the target value, so in our case we found our middle item to be 0 plus 15 is 15, floor division 2 is 7, so that's it's going to be at the 7th position in the list, and our index 7, so that's going to be a value of 14. That's where the middle item is. So basically, is 14 equal to 28? No, it's not. So no, we move on, we do the next check. Else if the value at the middle position is less than the target value. So is the value at the middle position less than the target item? So is 14 less than 28? As we can see above there, yes it is. So then we go in here and we set our low to the middle, the value of the middle plus 1. And basically, as we say, we're cutting off now the first half, because our target value lies after the middle value. We're going to cut off everything to the left. So bye-bye to everything to the left. So there's our new low now, which is index position 8. And as long as you don't cross over, as long as the low doesn't cross over the high, go back to step 3 above. So in Python, this means while low is less than or equal to high, as we'll see in a while. So we're back to step 3 now, and we're setting the middle value now to the low plus high, floor division 2. So this time our low is index position 8, so that's 8, plus high remains as 15, so 8 plus 15 is 23. Floor division 2 is 11, and therefore the middle value in this data set from here to here is now 11. And we're going to go off and do our checks again. So compare the value of the middle item in the data set, which is 25. We're going to compare that to our target value, which is 28. So if the value at the mid position is the same as the target value, so index position 11 in the list, which is 25, is 25 equal to 28? No, it's not. So we move on to the next check, and we say, is the value at index position 11 list, which is 25, is that less than 28? Yes, it is. So again, we're going to cut off everything to the left, or the middle value and the left of the data set. So that's basically only down as far as here now. And low now is going to become, we set low to the middle value, which is 11, plus 1, which is now 12. And that has now cut off this kind of part of the previous data set. And now we have a new data set with these numbers here, these ones, from 27 up to 37, which is index position 12 up to index position 15. So the low is now set to 12, and as long as the low doesn't cross over the high, so 12 is still less than 15, so we go back to step 3. We're going to get the middle value here, which is going to be 12 plus 15, floor division 2. So 12 plus 15 is 27, floor division 2 is 13, because 27 divided by 2 is 13.5. By taking the floor division, we get 13. So the middle value now lies in index position 13 in this particular data set. And we're off doing our checks again, and we're going to compare, is the value located at the middle item of this data set, which is 28, is that equal to our target value, which is 28? And yes, it is. So we go in then, and we're going to return our the index of the middle item that we just found, which is index position 13. And basically, that is it. 13 is returned as the value of the middle at that particular position. So this is the index of the target element, and how many comparisons were needed there. So I think we had 1, and then we had another one, 2, and then I think we only needed 3. in that. So see you in the next video for this idea of trace table.